Hi class, it's Bill Berry here with a continuing video in the series on creating databases, tables, and indexes. In the first video we learned how to create a database and we learned how to create simple tables that only needed plain column definitions with sort of simple attributes, and those were called column level constraints. For instance, we could create a primary key. So that's great if that's all we need, but that's really not all we need because we can't create foreign keys. That way we can't create composite primary keys, etc. So we've got some more to learn here. So let's jump down and continue where we left off. Table level constraints are what we use for things that we cannot do at column level. So what do we do with those? Well, how we add them is that after all the column definitions, we add what's called a constraint. And the way that the syntax works on that is you can optionally say the word constraint and you can optionally give it a name. Names are kind of nice because of the fact that when we work with database objects, we can create them, but we can also drop them. Sometimes we can modify them. So in this case, giving things a name that we generated, then we'll remember what they're called. If we decide that all this is optional, that's fine. SQL is going to make a name for it, but then you've got to go discover it if you want to learn, you want to use that thing in the future to get rid of it, for instance. So I recommend that in most cases you do that. So you say constraint, you give it a name, you say the name of the constraint. So we're going to focus first on, primary key. And notice that now you have different syntax where in parentheses you can give one or more column names. So if you want to create a single column primary key, you can do it this way. But if you're going to create a composite primary key, you must do it this way. You put the name of the first column, then a comma, and then the name of the second column. Right? This all goes again at the bottom after your columns are created because you're going to be referring to those, right? So you generally put all the column definitions first and then a comma and then you put the constraints. You can also say unique if you like. If you have column names, and again, you can put more than one column name. So if you want to force uniqueness on a pairing of those things, you could do that with a comma. That can also be done, remember, primary key and unique can both be done as a column level constraint if you have only one column in that particular thing. So those are useful. So let's look at some common things that we can do with that. Let's look at the pet adoption and let's see if we can figure out how to create the customer pet table. So let's see what we're going to do here, right? So let's bring up our handy dandy notepad window to write our SQL and we'll scoot it over. All right, so how are we going to create this table? Well, let me create the obvious stuff first and we'll discuss it. So this is a the basic start to this. You might be surprised that I said not null here, but unless we're doing a special thing with foreign keys, which we'll look at later once we understand those, unless you're doing a specific thing to allow foreign keys to be nullable, typically we don't want them to be nullable. We want them to have valid data. So we're going to mark those two columns as not null, and we're going to give them the data types. The adoption date, of course, marked not null, nothing surprising there. What we can't do here, this is something that you might want to try, and that is if you said primary key here and primary key here, right? You might think that that would work, but it will not work. It won't work, right? You can't do that. So you can't just put primary key in two columns and have it work. SQL is unhappy with that. We have to create this as a table level constraint. That means we need a comma here, and then we come down here. You don't have to say the word constraint, right? But I'm going to put it, and you can give it a name. One thing to note though, if you're going to give it a name for a primary key, it's actually not going to work, right? It's going to take away your name and just call it primary. That's just something MySQL does. So while you can name things, naming primary keys doesn't really succeed. So now what do we need to do? We need to set up the primary key, right? And then in parentheses, we put the primary key column or columns. In this case, what is it that we're going to do here? We're going to say it is a combination of the customer ID and the pet ID. Right? Because it is a composite primary key, we have to create it at the table level, and we're going to put it just like this, right? Primary key, and then in parentheses we're going to list those two columns. So that's how we would create the composite primary key that's required here. Now, that doesn't help us with the foreign keys. We're going to come to that in a second, but that's how you would do the primary key constraint for this particular thing. Notice the comma here, right? After the column definitions, you put a comma and then you go on. And if you had more constraints, you'd put a comma here. But if that's the last one, you can't. All right, so that's how that works. So there's our solution. Put your column definitions, and then here's the important point, the primary key. All right. Again, I just mentioned this, so read it if you'd like, and we'll go on. Now, there's one little advanced trick. If you want to see all the constraints that apply to a particular database, you can do it by saying select whatever from, and then it's called information underscore schema dot table constraints. And then you make sure that you say where constraint schema equals, and then this is the name of your database. So if you want to see all the definitions for constraints that have been created, you can do it this way. It's kind of a sneaky thing. This is a MySQL specific thing. Other kinds of SQL will have different places to look for this stuff, but it's all stored, right? And this will show you, hey, you have a primary key constraint, here's a unique constraint, whatever it is, you'll see all of these things. So that's just for reference. You don't need that. Okay, now here comes the really interesting and again referential integrity that is done declaratively. Here is the declaration for this. We've seen the primary key stuff, right? We declared the primary key, but the foreign key constraints are really interesting. So here is the detailed syntax for a foreign key constraint. You say optionally constraint and constraint name, great. Foreign key is required, and then in parentheses, no surprise, the column or columns that are part of that primary key. Be careful, very often you don't have composite foreign keys, so this comma and more columns is unusual, right? You shouldn't usually need that. But then the important follow-on is you need to say references, and you tell it where the table is for the primary key and what column or columns go with that. So this is the stuff about this table, and then this is the stuff about the reference table or the parent table. If you have two things listed here, you need two things listed here. But again, typically we have one column here and one column here. Now, another thing that we've been unaware of, and this is another good reason why studying this will illuminate a lot of interesting stuff, is that you can tell SQL what to do if the foreign key constraint gets violated, right? We don't want situations where that can happen, but if the user tries to do that, what should SQL do about it? And you have three different options. You can either say nothing, which means you're going to get this first option, which is called restrict, and that means don't let it happen, right? If they try to delete a foreign key or delete the primary key on which a foreign key depends, right? Let me say that again. If you try to delete a primary key data where the foreign key data exists, so you're trying to delete a parent, restrict means don't let it happen. It also means the other way around. You can't insert a foreign key that doesn't have a primary key. If the user tries to do that, don't let it happen. That's called restrict. So if you say nothing, you get that first option, which is called restrict, which also might be called no action in other SQL. The next option is Cascade. And Cascade says if you delete the primary key, you also have to go delete all the foreign keys that are associated with it. And if those foreign keys happen to be used somewhere else, if that causes a deletion of a primary key from that table, then go to the next table and delete the foreign keys for that, and so forth. That's why it's called cascading, because you can imagine this might delete a lot of data by deleting one and then the next and then the next, and it moves through all the tables till all of the orphans are gone, right? So I would think of this one as don't allow orphans. I would allow this thing as, call this thing as kill all the orphans, right? Sounds a little dramatic, but that's what it does, right? Kill all the orphans. So afterwards, there's no orphan data because it's all gone. And then you have a third option called set null. If you want to use this one, of course, you have to make your foreign keys nullable, which is a little bit odd, but you can. If you want the data to still be there, it can't be orphaned, so what it'll do is simply set those foreign keys to null. So you have those three options. The most restrictive and the most safe is, of course, restrict, right? Because it simply doesn't let you do the option. If you want to delete the child rows, go delete those first and then come back and delete the parent. That's up to you. So you have those options, but if you say nothing, you get this restrictive case, which is what we'd want, right? The safest case. So all that said, you can say optionally on delete and then give one of these words, restrict, cascade, or set null. Whew. Okay, so now we're going to look at how we'll create this thing using this intricate syntax. So let's jump in and do an example of that. Okay, bring up our handy dandy notepad. All right, so if we're going to create a foreign key constraint, how would we add that to the mix? So I'm going to say constraint. Now, we could name these things, right? So we could say something like this is going to be the customer pet underscore, customer pet ID underscore FK, right? So sometimes you name these things like that, and if so, great, right? If you're asked to do that, then great, do that. For the moment, I'm going to just leave that out. I'm just going to say constraint foreign key. And then, as it shows up here in parentheses, you have to put this. Now be careful, we're trying to create this thing, right? The foreign key for this, but remember, this is a single column primary key. This is a single column foreign key. This is not a composite foreign key, it's a composite primary key. So this thing links to that thing, and that's what we're writing here. So the foreign key here in the customer pet table is called pet ID. Right? Now, do note that the pet table has to already exist, right? I can't do this thing until I've done that thing. So you've got to create all your more independent tables first and then come back and add the ones that are linking tables or have the foreign keys for whatever other reason. Or, one-to-many relationships, etc. So we say constraint foreign key, we say what is the column in this table that I'm working with, and then you have to say references. And then what table is the parent for that? And that is pet ID. Sometimes it's hard to remember all of that syntax, right? So this is very intricate. So in this table, the pet ID column references in that table this column. Right? If you happen to have a composite foreign key, again, kind of rare, but you could, then both of these would have multiple columns. Okay. Now notice here there's no using or something like that. You can't just mention the common column name. You have to literally say them both. Now this also helps us explain why in some of our sample databases the names are not the same. So how does SQL know if the names are not the same? Because it doesn't matter. You're telling it the name in this table and the name in that table, so the names don't have to match for SQL to apply declarative referential integrity, right? So these are super clear on here is a constraint for my referential integrity, here's another constraint, right? So we are declaring those things. It is very explicit, right? So that's how you create a foreign key. Now we have another foreign key to create, which we won't do here, but to create this one you have to do a separate line. Oop, don't forget a comma here. That would be bad, right? That would be bad. So for the other foreign key, that's the customer ID, that references a different table, so you would need another line similar to this, but referencing the customer table's customer ID. But hopefully you get the idea here. It's intricate syntax, definitely the gnarliest syntax that we have seen, the most intricate. So that's an interesting piece. All right, so last things that we're going to talk about quickly here, you can alter columns. So once you've created the thing, you may need to make some modifications to a table. You can add columns, drop columns, or modify columns. If the data is not there, if you have no data in your table, it doesn't matter, right? Just go smash it and create the new table. But if you needed to, you could certainly do that. For instance, I can change the member table and I can make a new column, or I can expand a column. As long as you're expanding and there's data in it, it's going to figure out a way to take the old data and copy it into this. So if it was smaller before and this is now bigger, great, that's perfectly good. If you tried to make it smaller though, you're going to lose some data, right? So you have to be a little bit careful. Yeah, so give some room, or give a little room, and you can always make it bigger, but it's hard to make things smaller later. You can also get rid of columns as long as you don't mind losing that data. Can't do it if it's a primary key, and of course you don't want to do it if it's a foreign key as well. So you can work with existing columns. Now, there's going to be some other things that you may want to do as part of your creation process. You might want to create the tables, and then certainly in the assignments that I'm going to give you, I would suggest putting in sample data. In your assignments, I'm not suggesting, I'm saying you got to do some data. Why? Because we're going to consider all of this part of the sort of demonstration, the proof of concept that we have created the database in a reasonable fashion and can demonstrate its usefulness. So if we want to do that, we got to add some customers to the customer table, add some pets to the pet table, and then the interesting one is adding rows to the customer pet table, right? Because illustrating those adoptions through linking data is going to be interesting. Let us take a break though from this video because this one's getting long, so let's come back to this sample data in the next video and learn how to do it, especially the linking data gets really interesting. Thanks for watching this one though.